This is an equations video having a look at some key examples of simultaneous equations. Okay, here we have a pair of equations that we were asked to solve simultaneously. Now, just having a look at these straight away, there are no y's that match up. You know, we don't have 3y in both or 2x in both or whatever. So I'm going to create, in this situation, we need to create a match. So I'm going to call that equation 1 and equation 2 here, and I'm going to multiply every term in equation 1 by 2 in order to match up 4x in both equations. So I'm going to say, okay, my first line of working here is going to be 2 lots of equation 1. So I'm going to make a new equation out of that. If I multiply each of those terms by 2, I will get 4x plus 6y equals 28. Then I'm going to just write down equation 2 underneath it, because then I'll get the 4x and the 4x matching up in each. And what we can do there is we can subtract between each of the equations, and that will eliminate the 4x's. This is the elimination method here. So if I take 4x and minus 4x, that's going to be nothing. 6y minus, between the two equations, a minus 5 is going to give me 11y. Be very careful there. We have 6y minus 5y. So that's where that occurs. And 28 minus 17 is 11. Let's just solve that by dividing by 11 on both of them. And we get y equals 1. That's pretty cool. And we will then substitute for the second bit. We'll just substitute that answer into one of the two equations here. Let's substitute y equals 11 into equation 1. So we have 2x plus 3 lots of y, so we're going to substitute that into as y equals 1. Sorry, that should be y equals 1 there. That was our final answer there, y equals 1. We'll substitute that in wherever there's a y here, so we're kind of like we're putting that value of y into there, and then we'll just have numbers and an x, so we can solve for that there. So that creates, when we substituted y equals 1 into equation 1, we were left with 2x plus 3 equals 14, and we're able to just solve that in the normal everyday equation solving techniques of moving numbers by doing the opposite to both sides. And we'll divide that by 2, leaving us with x equals 11 over 2. Now when we've got our solutions here, y equals 1 and x equals 11 over 2, we'll just put them together to make a final answer. So just to recap, we saw that none of the terms were matching very nicely, and so I took the decision to double each of the terms in equation 1. So then we got a couple of matching equations over here that we were able to subtract between, so that we eliminated the x values at first. We solved that result and then substituted that back into, in this case, equation 1 to find the x value as well. Alright. So here, solving this simultaneously, it's an interesting question because you have this whole chunk here that's actually equal to y already. So this lends itself to a substitution method, whereby wherever there's a y in this first equation, which I'll call equation 1, I'm going to substitute in the y value, or the expression that is for y, from the second equation here. It's interesting, but it's a way of merging the two equations so we can solve them simultaneously. So I'm going to basically say here that I'm going to sub y equals x squared minus 4x plus 4 into equation 1. That's what I'm getting at in this first bit. So instead of 2x minus y minus 5, I'm going to have 2x minus, in brackets, careful with this, x squared minus 4x plus 4 minus 5, that's the rest of the equation here, equals 0. Now when you've got a minus in front of these brackets, what the effect of that is, it's like a minus 1 multiplied through here, and what it does is it changes all the signs around there. So let's just process that here. We get minus 1 lots of x squared, you'll get minus x squared. Minus 1 times that will make positive 4x. Minus 1 times positive 4 is minus 4. Minus another 5 equals 0. We'll collect some like terms here. We've got a 2x and a 4x here, making 6x. A minus 4 and a minus 5 would make a minus 9. And it's not easy to work with minus x squareds there, so we're allowed to actually change all the signs there. It's like we'd multiply this whole left hand side by minus 1 and the right hand side by minus 1. So we're allowed to then say x squared minus 6x plus 9 equals 0. And if we did PSF on that, we'd have a product of, so this ends up being a quadratic, it's quite unusual, 9, 6, and we'd have minus 3 and minus 3 as our two numbers there. So we end up with x minus 3 and x minus 3 equaling 0. So basically x minus 3 must equal 0, x equals 3. Okay, so then we found our first value, x equals 3. Now over here, I think I'll use this space over here now. I'll sub x equals 3 into, I think I'll go with equation 2 because it's got a y equals already. So let's say y equals, instead of x squared, I'm going to put 3 squared minus 4 lots of 3 plus 4, 9 minus 12 plus 4, y equals 1. And then we'll just write that down next to the x value that we found as our last solution there. Alright, now that's a very unusual one because when we substituted that in, we had to then solve a quadratic equation, which is like we did in the last video. So it's probably good that you just had a look at that one, perhaps if you're going in order. Alright, so that was a substitution one. It lended itself to substitution because from equation 2 we had a sort of an expression for y which we could replace y with in that first equation. So in each of these cases we're merging the equations really as best we can and then solving the results. Alright, now this is an unusual triple-barreled one here. It's a bit of a challenge. What I'd suggest is you take this easiest equation, and wherever there's an m, I think you should put a 3. So by doing that, that's equation 1, that's equation 2, that's equation 3. You are progressively making the equation more doable here. So I'm going to suggest that we're going to replace that m in that second equation with a 3. So we're going to say sub m equals 3 into equation 2. So that will give us 3 plus n equals 12. If we solve that, we'd minus 3 both sides. N equals 9. Now interestingly, the first equation is actually one of our solutions. In the end we're trying to find m, a value for m, n and p. They've very helpfully told us the value for m straight away. So that's pretty handy. And we just found a value for n. So now equation 3, we're going to substitute in m equals 3 wherever there's an m, n equals 9 wherever there's an n, and then we should just have p on its own here. So instead of m, I'm going to put a 3 plus 2 lots of n, but I know that n is 9 here, minus p equals 32. And if I get p on its own, I'll be able to solve this equation for p as well. 3 plus 18, 2 lots of 9 is 18, minus p equals 32. I could join those together and make 21 minus p equals 32. I could minus 21 both sides if I was able to write neatly. Minus p equals 11, and then I could just say p equals minus 11 in that situation. So our final results here were m equals 3, which was very nice of the question to give us straight away, n equals 9 by working on the second equation there, and p equals minus 11. That was our set of results in the end. So those ones aren't easy, but sometimes you have to merge what you know from the first equation into the second, and then the combined one you can convert into the third. So you progressively try and solve each value as you go, but it's a bit trial and error, that one. You have to sometimes you have to have some strange combinations and you're going for quite a while, but you're just trying to not make any mistakes with your algebra and your solving of your equations along the way. But yeah, keep calm and carry on. Alright, so there's a few key simultaneous equations solutions for you to follow. Hope that helps, and I'll see you next time. peterblakemaths.com. All the best.